Hey, this is dumediat. I'm back here on BremSter's channel today to bring you a puzzle called Squaring is Sharing by Wuschel. It's been a little while since I've recorded a video for BremSter, so I'm excited to get back into it. Let's get into the rules. So we have normal Sudoku rules. Each row, column, and 3x3 box will have the digits 1 to 9 once each without repeats. We have arrows in the puzzle, so the two digits along the arrow will sum to the number or the digit that we place in the arrow circle. It doesn't matter in this puzzle, but if you would be allowed to repeat digits on arrows if allowed by other rules. We have killer cages, so the digits in a cage may not repeat, and they sum to the number in the top left corner of the cage. So these 4 digits we place in here must sum to 21. These 4 digits must sum to 20, and so on. And finally, we have ratio dots. So 2 cells separated by a black dot will contain digits that are in a 1:2 ratio. So for example, if I were to put a 2 in this cell, I could fill this cell with either a 1 or a 4. Or if I have a 3 here, then I could place a 6 next to it. Those are the rules for the puzzle. I'm going to go ahead and restart my timer. And let's see if we can solve this puzzle. And I've played, I'm a little fortunate, I've played with this type of geometry before with 2-cell arrows with a black dot on them. And a couple of things we can say immediately about them is we know that this cell is, for example, is going to equal the sum of these 2 digits. But these 2 digits are pretty restricted because of this black dot. So if we were to put, for example, the lowest two, 1, 2, we'd have a 3 here. The next valid way to fill this black dot with higher digits would be 2, 4, which would give us a total of 6. And then the next higher pair of digits on the black dot could be 3, 6, which would give us a 9 here. And we can't do 4, 8 because that would give us 12, which is not allowed. And you'll notice something interesting here is this arrow circle will always be 3, 6, or 9. So it's equally divisible by 3 without any remainder. So the reason for that is if you think of, let's imagine this is the smaller digit on a black dot, and this is the larger, we double it. So you can think about this as 1x plus 2x, so 3x. So this is always going to be divisible by 3. I won't leave this in here. But one other interesting property of this construction here is if we could put 3, 6 on this dot. I kind of think of black dots as 2 separate sort of groupings, either 3, 6 or from 1, 2, 4, 8. Because the only way, there's only 3 6s available. If you have 1, 2, 4, and 8, you have a few different ways of making that, but they both use totally separate digits. And so on here, if we were to use 1, 2, we'd have a 3 in this bulb. 2, 4, we'd have a 6, or we have both 3, 6 on the dot with a 9 here. So we're always using at least one of 3 and 6. So this black dot, for example, and this one even, because there's the exact same construction in these cells, these can't be 3, 6. If we did that, if we put 3, 6 in here, we know this is 9, but then this would also have to be 3, 6, and that's going to break. But I just remembered too, let me turn off my, I think I had my pencil mark checker on. Yeah, I do. Let me turn that off. So we know this can't have 3, 6 on it because it would break this arrow. So both of these are going to be from 1, 2, 4, and 8. We know this and this, all of these are going to be from 3, 6, 9. And the other thing, well, we can't necessarily say, we know we have at least one of 3 and 6. We might have both. We don't necessarily have anything from 1, 2, 4, 8. If this is 9, 3, 6, then we don't really touch this one. I am noticing though, this one can't be, yeah, this one can't be a 6. Because if we did that, if we made this a 6, let's just do that for now. This would have to be 2, 4. And this 2, 4 comes out of this black dot. and that would have to be a 1/8, but 8 is not double 1. So we actually can't have 6 in either of these two, because in either case it's going to break these black dots. So we have 3 and 9 in these two. We could have 1, 2, 3, and then 4, 8. That does work. Wondering, there's this kind of suspicious geometry here where we've got a 27 cage. Does that have to have a 9? If we don't, it's 5, 6, 7, 8, which is 15 plus 11, 26. Yeah, so this does need a 9. If we don't use an 8, we only get up to 26. Or if we don't use 9, we only get up to 26 as a maximum. So the other 3 digits in this have to sum to 18. So what happens if both of these are the same 3, 9? Let's just say they're both, it doesn't really matter. I don't think they can both be 3, because that'd be 1, 2, 3. The reason I'm saying this, imagine this is 1, 2, 3. And this is 1, 2, 3. By Sudoku, we would need to have the 1, 2, and 3 couldn't be in any of these cells, so we'd have 1, 2, 3, 9 in here, but that only sums to 15. So that doesn't work. What if these are both 3, 6, 9? Does that work? I don't think so, because again, by Sudoku, 3 and 6, well, we already know 9's in here, but 3 and 6 can't go in here. So we'd have 3, 6, 9, which sums to 18, and we need to get another 9, but we'd have to repeat the 9 in this. So we'd have double 9 in this 27 cage. That's really cool. So, and the reason I noticed that is because this is also divisible by 9. So if we have 3, 6, 9 here and 3, 6, 9 here, that's this would be 18 plus 18. So we have 18 in here, those 3 digits plus 9, but we've already used the 9, so we'd be doubling the 9. So this is actually a different, one of these is a 3 with a 1, 2, and the other one is a 9 with a 3, 6. So we've always got a 3 on here. Either the 3's in the circle or the 3's on the black dot to make 3, 6, 9. So there's always a 3 in both of those, which means there's a 3 in the 27 cage by Sudoku. And we've got to 12. We need another 15. We can't use 6, 9. So this is have to be 7, 8, and then 3, 9. Nice. So we've got at least the makeup of the 27 cage, even if we don't know where they go yet. Oh. And then this cell here sees a 3, 9 pair. One of these is 1, 2, 3, one of these is 3, 6, 9. So this has to be a 6, actually. 2, 4 here. What does that do for this 20 cage? Not sure yet. Hmm. 6 is up here. It's 2, 4. These are from 1, 2, 4, 5, and 6. But this is probably more restricted than that because it sees both. So one's a 1, 2, 3, and one's a 3, 6, 9. So we've got 1, 2, 3, 6, 9. So this can't be any of those digits because it would rule them out. So for example, if this is a 1, neither of these could be our 1, 2, 3 arrow, and they'd have to both be 9, but we've already said that that doesn't work because of this. So this can't be 1. One of these is 3, 6, 9, so we can't have a 6. And one of them is 1, 2, 3, so we can't have a 2. Okay, so that's a 4 or a 5. That's interesting. So whatever one of this is a 1, 2, 3, then 1 and 2 in box 1 have to be here. Same thing if this is 1, 2, 3, the 1 and 2 goes up here. That would kind of be interesting. Well, kind of makes me wonder about this cell because, yeah, if we have 1, 2, 3 here, we take the 1 and the 2 out of this, so there's the 1, 2's over here, and this becomes 4, 5, 6. So we have 1, 2, 3, 4, 5, 6, and these 3 cells would be 7, 8, 9. The other option would be that this is 1, 2, 3, 4, 5, 6, and 7, 8, 9. But if this is 7, 8, 9, we already said before, this can't be any higher than 6 because it's either 1, 2, 2, 4, or 3, 6. So that's 1, 2, 3, 4, 5, 6. This cell is going to be without a fill, so this can't be the 1, 2, 3 arrow. Nice. So this is our 3, 6, 9 arrow. And this is our 1, 2, 3 arrow. And this 1, 2 pair comes out of here. So we've got a 4, 8. The 1, 2 comes out of here. And this becomes a 1, 2 pair. The 1, 2, 3, 6 looks down here, making this a 4. Which makes that a 2 and that a 6. That's not 2. So that's not 1, because if this is 1, this would have to be 4 or 8, and that doesn't work. This 4 looks like making this 5. And this is 7, 8. And this over here is our 7, 8, 9 that we talked about before. That's pretty cool. I like that geometry going around. We don't need these colors anymore. Okay, 6 by Sudoku in this box is here, and so it's down. Actually, it's in the 20 cage because of this 6. We've got these 6s looking, so that pulls 6 out of these cells. So 6 goes in the 20 cage. Oh, that's interesting. So 4 cell cage with an even total basically needs an even number of even digits, or an even number of odd digits, whichever way you want to look at it. So if we've got a 6 in here, we can't have 3 odd digits in here because that would be 3 odds, which is odd, plus an even, which makes it stay odd. But this is an even total. We've already got 2 and 4 used up, so we also need an 8 in this 20 cage. So the 8 looking down puts it there, which then puts an 8 in this 20 cage. Oh, that's cool. Yeah, so that's the logic's gonna repeat there. We need another, at least one more even digit, or they'd all have to be 4 even digits, but we've got a 6, so we need one more even. But in this column, we've got 2, 4, 6 used up, so we can't put the other even here. So we've got to put it here, and 6, 4, 8 are already used up, so there's a 2 here. That 2 looks up making that 1 and 2. There might be other ways if you use the killer calculator, but I'm trying not to use that for this solve. But here we've got a 2, 8, so we need 2 more odd digits that sum to 10. That could be 1, 9, or 3, 7. I don't think we know which one yet. And this is 6 and 8 is 14, so we need 2 odd digits summing to 6, which has to be 1, 5, because we can't use 2, 4. So this is 1, 5, 6, 8. The 6 is not here. The 8 is not there. The 1 isn't there. So this is a 5, 6 pair. This is a 1, 8 pair. The 1 by Sudoku makes another 1, 8 pair here. Okay, so now we said we needed 2 more digits that sum to 10. So we've got 2 8, and then 1, we need a 9 here. Nice and smooth so far. 1, 2, we need 3 and 7 still in this column. And in this column, we need 2, 3, 5, 7, 9. There's already a 5 here. This box still needs 3, 7, 9, because we've already got these 3 pairs. So then the rest of this row 9 needs 1, 5, and 8. Okay. This black dot can't be 1, 2, because if it was, it would take all the values out of this cell, so this isn't a 3. This is the 7, 9, so there's a 5, 7, 9 triple, but the 5 is up here. And so this is 6, 7, 9. All right. Just seeing if I missed any Sudoku here. I know there's a 2 and 5 and a 4 over here, but I don't think we know much more than that. What about this over here? I'm looking at a couple of these killer cages where we know a little bit about them. Let's start down here. So I'm just looking at the combinations. If this is 1, 5, I'm just seeing if we can omit 8 from here. If this is 1, 5, then we need these to sum to 14. They'd have to be 6, 8. Oh, but they couldn't be. Yeah, this is 1, 5. This is 8. And so this sums to 6. We need this to sum to 14. We can't use 5, 9. And we can't use 6, 8. So that doesn't work. So we do have an 8 there. And not here. And then, so this is either going to sum to 9 or 13. If this is 1, 8, it's 9, this sums to 11. I think there's some options there, because this would be 1, 8 with a 5. So it couldn't be 3, 8, or 5, 6, but it could still be 4, 7, or 2, 9. If this is 5, 8, that's 13 with a 1. This would be 3, 4 to make the 7. I think that works. Might be looking in the wrong spot. What about here? Because I'm noticing maybe this black dot will help us. So we know this is 2, 4, or 3, 6. Okay, so this is at least 15, 7, 8. So this is at most 6. So this is from 1, 2, 3, 4, 5. So the question now is, where does this digit go in box 3? If this is a 6, well, whatever digit it is, it's going, it can't go on its own arrow, obviously, because then the arrow is broken. This is a minimum of 6, so it can't go in these cells. Can't go in these cells because of the arrow, and it can't go in these cells by Sudoku. So this cell goes in one of these two cells up at the top. And we can't put 6 up here because we already have a 4-6 pair from the break-in logic. So this has to be a 9. Very nice. So that 9 goes up here in the 21 cage. This is a 3-6 arrow. Get rid of the colors here. 3-6, there's no 3 here. There's no 6 here. So the 6 in box 2 goes there. The 3 comes out of here. So there's a 3 in one of those two cells. Okay, so just checking other Sudoku. I don't. 9's here somewhere, but yeah. Oh, this 9 looks over, making this 2 and this 9. 2 comes out of here, so this can't be 1, so we've got a 4-8, which then looks back at the 1-8. Nice. 8 by Sudoku goes down here. This isn't a 4. What I was going to say, just making sure I don't have any more Sudoku just sitting here. I don't think so. I was going to look at these again, because I said if this was 7-8, these had to sum to 6, and that still works. If this is 7-9, that's 16, that sums to 5. That would be 1-4. I don't see a problem with that. Oh, I do see a 7-8-9 triple in row 3 here. That's going to help us a lot because first, the 8 is over here in the 7-8-9 triple, so there's no 8 up here. But if this looks over, this is 4, this is 8. And then this, it can't be 7 or 9, so it's 5. So the only thing left for this row, we've got a 1-2 pair. We've got also a 3-7-9 triple in row 2. So we have a 1-2-4-5 sort of quadruple with this row because we've got 3, 6, 7, 8, 9 taken up. But the 4 and the 5 are over here. Okay. What else does that give us? What are these? I'm just checking to make sure I didn't miss anything else, but I don't think so. Oh, yeah, I am. This 6 looks up, making this 4, 6. The 4 makes this 8, 4. So the 8 looks up and there's no 8 there, so the 8 is in this cell. Okay. All right, this box still needs 1, 2, 5, and 7. There's no 2 here by this 2, so there's a 2 in the 18 cage. Maybe that'll be interesting. And there's a 4 in the 18 cage, because earlier we said there's a 4 in these 3 cells, but we ruled it out of this cell by that 4. There's a 2 and a 4, so we have 6. We need 2 more digits that sum to 12. So we can't have a 1 here because we need an 11. We could have a 5, 7. We have 2 plus 4. So what are the other ways to make 12? 3, 9, which doesn't work because we can't have 9 in this cage at all. We can't use 3, 9. We can't use 4, 8 because we've already used the 4. Plus we can't have an 8 in the cage. So the only other option is 5, 7. So it's a 2, 4, 5, 7 cage. Okay. The 2 over here. Now this can still be a 5, I think. Because then the 5 would just be over here. Just think if I could roll 5 out of this cell, but I don't see how I can do that. Six, 1, 8. Get the 8 down here, so don't think I could do anything more with this yet. Oh, I do know there's a 1 here. So 1 is there. These 3 cells are 3, 5, and 9. Doesn't really help us. Where am I missing? 5, 6, 7. Just looking at these 7, 9 pairs. I don't think they helped us yet either. Is there something with this? This was either 15 or 16, so this is either 5 or 6. I mean, one small deduction I can make here is whether we're making 5 or 6 here, I'm using a 1 or a 2, because if not, it's 4 plus 5 is 9. And we've got a one of the 1, 2's here, and the other one is here, so this isn't 1 or 2. Okay. 2, 4, 5, 7. What about this? Is this restricted somehow? So if this is 1, 8, that's 9. This has to be 11. To be 2, 9, 5, 6, or 4, 7. Not 5, 6, because that would break this. So it'd be 2, 9, or 4, 7. And if it's 13, this is 7. So 1, 8. This would be 2, 5, or 3, 4. Can't be 2, 5, so it would be 3, 4 for sure. So this is 5, 8. This is 3, 4. This is 1, 8. That's a 5. You have to make 11. So it would have to, it can't be 3, 8 because the 8 would be used. It can't be 5, 6. It'd be 4, 7, or 2, 9. It doesn't really look super useful. So then what am I missing? It's not there. Is it this cage? I hope I'm not just missing something simple by Sudoku at this point, because it seems like it's been really smooth up until right now. That's usually my hint that I missed something. Just scanning Sudoku. I'm not seeing anything obvious. I did this math right, 2, 4, so I need 12 more, yeah. "21 cage just doesn't seem restricted though, because nothing is restricted around it." I'm just checking the killer calculator while I'm here. I know there's an 8 in this cage with a 1 or a 5. Yeah, so there's still options there. Sudoku again. Two, we already have got taken care of. 3, we don't know much about it all, really. 4. Don't know anything about 7s yet. Okay, so what's this has to be the last step of the puzzle here. I mean, the only other restricted row here at this point in the puzzle is this one, 3, 5, 7, 6. This isn't a 6. So one of these is a 9. Another pair I'm missing, or a triple somewhere? Looking up the columns here now, we haven't looked at it in a little while, but I think this would be, this has a 9 in it. I'm gonna double check this one too. Doesn't have a 3 in it. And it doesn't have a 6 in it. Is that what I missed? Oh, yeah, this is 7, 9. This is only 1, 4. This was 7, 8. What I didn't look at before was these are 6. 7, 8. Yeah, I was doing the math wrong the entire time. I apologize. This is either 7, 9 or 8, 9. 8, 9, of course, is not possible because this would be 17. These would have to sum to 4, and 1, 3 doesn't work. So this is a 7, 9 pair. Y'all have been yelling at the screen at me, I know. So 7, 9, 1, 4 with 5. 2, 1, 2. Well, at least we'll make progress now. And probably this will finish off the puzzle at this point. This 8 and 5 looks down, making this a 1. That's an 8, and that's a 5. These sum to 9, so these have to sum to 11. So this can't be 2, 9. We can't use 3, 8. Okay. This can't be a 2, so this can't be a 9. So we've got a 4-7 pair here, making that a 2 and a 4. The 7 makes this an 8, and this a 7. The 8 makes this the 1, and this an 8. This 1 looks over, makes this the 1. This is 3, 5, 9. Okay. Making sure I didn't miss any other Sudoku while I got all those digits. What does this column still need? 3, 4, 6, 7. This can't be 4 or 7. This isn't an 8, so we've got an 8 in the 21 cage. This 8 ruled that out. So we need 3 digits to sum to 13. Also looking over here, we need a 2 in this row, so we've got a 2 here. I do like in this puzzle where I get like 1 digit in these 4-cell cages, and by Sudoku there's almost always been another digit locked in the cage, so I haven't had to do like 3-cell math. They've only had to do 2-cell math, which obviously I don't understand very well. So we have a 2 and an 8, so we've got 2 more digits that sum to 11. Can't use 2, 9, 3, 8, so it's either 4, 7 or 5, 6. Can't be 4, 7, which is interesting. So if it was 4, 7, they'd both have to be up here because of this 4, 7 pair and this 4, 7 pair. So this would be 4, 7, but then the 8 needs to go here also. Okay, so it can't be 2, 9, 3, 8, 4, 7, so it's 5, 6. 6 goes down here with the 2, and the 5 goes here with the 8. 2, 6 makes this a 3. There's no 3 here. There is a 6 here by this triple. There's no 6 there. We got a 3, 5, 7 triple here, so this is the 6, this is the 3. This 4, 7 doesn't do anything, but this 2, 6 looks over, making this 5, 6. 5 and the 3 make this a 9. This 9 takes 9 up here. Okay, I think we're getting close to done here. 5, 8 looks over, taking 5 out of this cell. 5 out of this cell. 5 out of here. 6 looks over, making this not the 6, so there's 6 and column 9 is there. Okay, so this is a 2, 4, 5, 7 cage. The 5 is in one of these 2 cells, so this is not 5. So this is a 1, 7 pair, making this a 3. This a 5, this a 3. This 1, 7 pair makes this a 2 and a 5. Just takes 5 up here. Got a 4, 7 pair now in this cage, and just checking the math. 11 plus 7 is 18. Okay, 3, 5. The 4, 7 makes this a 9. It's a 3, 7, 9. This 9 makes this a 7 and a 9. This is a 4, 7 pair, so this makes this a 1, 7, 4, 7, 4, 7, 4. That makes this a 1 and a 4. This box needs a 9. This 5 makes this an 8 and a 5. This 9 makes this a 7 and a 9. This 9 makes this a 7. There's a 5 in this box already. This 7 looks done, making this 3, 7. This 3 makes this a 6 and a 3. This 6 makes this a 2 and a 6. And this is a 1, 2 pair, which is resolved. Very nice. Probably shouldn't have taken me 38 minutes. I spent a lot of time, obviously, making a mistake with my math up here. But ignoring that, if you don't mind, Wuschel, this puzzle had really cool geometry. I really like this break and idea, just using kind of this construction with the black dot on the 2-cell arrows, and the fact that you couldn't have the same 3 digits appearing with the 9 in this 27 cage without repeating a digit or not getting to the right total. And that gave us this, this 3-9 pair gave us a 6 to get going. And then just kind of really nice placement of these 4-cell cages, which always, like I said before, seem to have, as soon as you got 1 digit locked into it, you almost always had a second. So it made the math a lot easier. There's some cool tricks with parity in the 20 cages here as well. Thanks, Wuschel, for the puzzle. Thanks, BremSter, for inviting me back. This video is long enough, so I'll end it here. Thanks for watching, and hopefully we'll see you again soon. Bye for now.